Welcome to MyProjectBazaar.com. Let we discuss about the process non-regenerative multi-way relaying with linear beamforming. Let we discuss about the abstract of the project. Multiple node communication system is proposed which are located in the half duplex multiple antenna relay station. The multi-user communication channel in which multi-users exchange information based on the multi-way approach. Decode the message of each node from all other nodes. The number of nodes decides the number of communication process. For a single phase, message of all nodes transmits simultaneously to the RS next phase of the RS transmits to all nodes while using transient beamforming. In this process, three linear beamformers are used such as zero forcing, minimum mean square error and maximization of signal to noise ratio. Performance are evaluated with achievable sum rate for both asymmetric traffic and symmetric traffic. In asymmetric traffic, all nodes are communicated with minimum traffic rate, whereas in symmetric traffic, all nodes are communicated with the same traffic rate. Those mentioned beamformers are allow low communicational complexity transient beamforming. It is a general signal processing technique used to control the directionality of the reception or transmission of a signal on a transducer array. In multi-way communication, if all n nodes are half duplex and there are direct links between them, the required number of communication phases in order for each node to obtain the information from all other nodes is n. Let me discuss about the flow diagram for our process. Initially, here beamforming methods are used. Here there are zero forcing, MMSC, MSNR and phase transient beamforming are used. Initially, channel matrix transmitted signal and AW noise vector are designed for generating the signal. Then in the transient beamforming, there are three processes will be performed. One is generated signal and another one is RS propagated noise and another one is interference signal. Finally, we receive the received signal. With the help of received signal, we analyze the performance graph. The performance graph for both asymmetric traffic and symmetric traffic. Here, interference cancellation algorithm is considered for reducing the interference. In the zero forcing beamforming method is a special signal processing in multiple antenna wireless devices. For downlink, the ZF BF algorithm allows a transmitter to send data to desired users together with nulling output the directions to desired users for uplink. ZF BF receivers from the desired users together with nulling out the directions from the interference users. If the transmitter knows the downlink channel status information perfectly, ZF based pre-coding can achieve close to the optimal capacity, especially when the number of users is sufficient. With the limited channel status information at the transmitter, ZF BF requires the amount of feedback overhead proportion to the average signal to noise ratio to achieve the full multiplexing gain. Hence, inaccurate channel state information at the transmitter may suffer the significant performance loss of the system throughput because of the interference among transmit stream is remained. In the minimum mean square error, the minimum mean square error algorithm minimizes the error with respect to a reference signal. In this model, the desired user is assumed to transmit the reference signal where the signal amplitude and receiving base station are considered. The output is required to track this reference signal. The MMSC technique minimizes the error with respect to a reference signal. This technique therefore does not require knowledge of the spatial signature. In multipath fading environment, MMSC beamformer gives optimum results. This beamformer utilizes the reference signal which is correlated to the desired signal and uncorrelated with the interferences. Next, the maximization of signal to noise ratio. MSNR beamforming criterion leads to a simple eigenvalues problem, so that the weight vector is the principal eigenvector of the covariance matrix of the desired signal. The receiver exploits the MSNR based beamforming for spatial processing. There are different algorithms like the power method, the Lagrange multiplier method, and the conjugate gradient method to solve the scheme. Finally, the phase transfer beamforming are used. Reciprocal and stationary channel within n phases. We can compute the transfer beamforming only once by defining the transmit channel matrix, permutation matrix, to define the relationship between receiving node, transmitting node, and the corresponding phase. Finally, we analyze the signal to interference noise ratio. SINR is a quantity used to give theoretic upper bounds on channel capacity in wireless communication systems such as networks. Analogous to the SNR used often in wired communication systems, the SINR is defined as the power of a certain signal of interference divided by the sum of interference power and the power of some background noise. If the power of noise term is 0, then SINR reduces to the signal to noise interference ratio. Conversely, 0 interference reduces the SINR to signal to interference noise ratio. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, right click the file and run for executing this process. Here we perform the non-regenerative relay placement. Here the both beamforming methods are used for performing the symmetric and asymmetric model. Here we obtain the average sum rate for our symmetric and asymmetric model, and here we consider both interference cancellation and without interference cancellation. This is the sum rate performance for asymmetric traffic. Here we consider with interference cancellation and without interference cancellation algorithm, and in this model we perform sum rate performance for symmetric traffic. Here the average sum rate versus SNR graph has been plotted. Here they have considered with interference cancellation and without interference cancellation algorithm. Finally, we perform the perfect beamforming methods with interference cancellation algorithm for reducing the interference collision. Thank you.